This is just a little bit of a midway review in what we've learned so far about system software. We've been talking about system software, and in particular, as a subcategory of system software, we have been talking about operating systems, and we've learned some great things about operating systems. So I'm going to give you a quick little review of what we've learned here so far, because reviewing material makes it stick. The more you roll around in anything, the more it sticks to you. So repetition is key, practice is key. Drop by drop, the bucket gets filled. So just a little bit of a review of everything we've learned so far about operating systems. So an operating system, the most basic definition is it makes your system operate. It's a very reflexive definition. So it manages and coordinates the activities within a computer. And super important to know is this one little diagram right here that shows sort of a tiered system, a layered cake kind of layout of how the operating system fits in with all the different kinds of categories within a computer or junk stuff within a computer. We've got the hardware on the bottom, and hardware can be very specific. Whoever's making the hardware gets to decide how they make it. In particular, what I mean by that is that when a CPU gets made, it has a unique instruction set. And different manufacturers of different CPUs can make their CPUs to work with the same instruction set, so there are common instruction sets. But when there is a CPU with a certain instruction set, a specific instruction set, the operating system has to be written to specifically work with that instruction set. So each operating system has to be written to work with a specific set of hardware and to tell that hardware how to work. In fact, it is the job of the operating system to make the hardware work, to make the system work, to make the system operate. That's what an operating system does. It makes the system operate. So the operating system really is what is making the hardware work, and it's kind of like a traffic cop, right? It's saying what gets to happen when inside the computer. So the operating system interfaces with the hardware, and that is fantastic because whoever writes application software does not have to worry about making the hardware work. You just write your application software, and you don't have to write any software. If you're like writing Microsoft Word, you don't have to worry about how to make every printer in the world print a document when the person who's using Microsoft Word finally wants to print. All you have to do is write your Microsoft Word to work with a certain operating system, and that operating system will know how to make different printers print the page. So when Microsoft Word is ready to print something, the user says, print this. Microsoft Word says, okay, and it gives that to the operating system. The operating system then knows how to make the hardware print. It makes the hardware print. The hardware then says it's been printed and tells the operating system it's been printed. And the operating system then tells the application software, Microsoft Word, that, hey, we printed this document. Microsoft Word tells you, the user, this document's been printed. So that's kind of how it all works. And the operating system is in charge of making the hardware run. So the operating system manages and coordinates activities within a computer, makes the hardware run. And all OSs are CPU specific to a certain CPU's instruction set. Super important to know. We looked at different types of operating systems. We categorized them by size. We said, hey, there's different sizes of computers. And for each of those computers, we got different operating systems. For the supercomputers, we saw that Linux was what is being used on the Titan, which was amazing. We also looked at mainframes, and we saw that mainframe operating systems generally tend to be IBM operating systems. We looked at server operating systems and how there's pretty much Windows Server and Mac Server and Linux Server. We looked at desktop operating systems, and we saw that Windows dominates the market. Microsoft Windows dominates the market. Mac comes in at a measly unwarranted 10%. Mac really deserves to have much more market share, but for whatever reason they do not. And we also saw that Linux was a free open source operating system which you could download. You can download it for free. Go to Ubuntu, and you could get a brand new operating system for your computer and throw away whatever operating system you're currently using just by going to download here. But Linux was another operating system, and it is an open source operating system, meaning that the source code is open to anybody in the world who wants to download it and look at it and improve it and then upload the new improved version. And a lot of computer programmers who aren't married and live in their grandmother's or their mom's garages or basement and they have nothing to do at night, they do download that code, they make it better, and they upload it for free just because they like to program and it's what they love, and so they just do it. And it's an amazing thing. Linux, mobile operating systems, iOS and Android running on your mobile devices, right? And then we have embedded operating systems, like in my wristwatch, right? There's got to be something in there making that hardware work. It's an embedded operating system, and I sure as hell am not going to be able to update it. It's just built right into it. So those are the different operating systems by size. We also saw that there are other categories for operating systems, like real-time operating systems, which is pretty much what we use now. They're event-driven. There are multi-user operating systems, which allow many people to connect to the same operating system computer at the same time. And then we also have distributed operating systems, which takes multiple computers and makes them, uses the resources from multiple computers, and one operating system is running on all those multiple computers. Pretty interesting stuff. All kinds of things out there. Really basic, right? You don't have to get complex about it. Installing it, finding which one you want. You know, if you're interested in, like, okay, I got 30 computers in my garage. I want to run an operating system, just one operating system on all 30 computers, and maximize the computing power of all 30 of those computers in my garage. You could then go to Google and say, I want to find a good distributed operating system. Where's a good distributed operating system that will run on all of these different computers at the same time and take advantage of all the processing power of all those computers? And what you'll probably find is some flavor of Linux. All right. We also looked at the different functions of an operating system. I really think the main function of an operating system is just to make your system operate. That's all you got to know. It makes your system operate. But you're going to, or take it a little bit deeper, it makes all the hardware work. It knows how to make the hardware work. Or take it a little deeper, it manages and coordinates activities within a computer. Or take it a little bit deeper, right? It provides a user interface, like a command line user interface or a graphical user interface. And it also finishes the booting process. It configures the hardware when it's doing that. It interfaces with the hardware and it runs the hardware. And it manages the hardware, is what some people call that. It manages networking. It manages security. And it manages resources and scheduling of jobs. So it's that traffic cop that gets to say what happens when inside the computer. It provides file management, so it knows how to store things on disks for you, whether it's FAT32 or NTFS. And it also allows you to go into Windows Explorer and find all your files. All right, so there we go. And lastly, there's a few phrases where it starts to get a little confusing, where we start to descend a little bit into that rabbit hole of Alice in Wonderland, where it gets like, okay, too much information, TMI, 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 retreat, 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 back up. We learned that there's a few things like multitasking, which basically means your computer can run multiple programs at one time. It hasn't always been so. That's multitasking. Multiprocessing means that a computer is working with multiple processors at once, and multiple processors working on separate tasks. And parallel processing is multiple processors working on the same task in parallel, which is difficult to do. And that's what you find sometimes in servers and mainframes. A few last things to point out. We looked at the different types of operating systems that are out there in the marketplace. The main types that are out there, we got Mac OS X, we got Windows. All right, we went over this Linux, Android, iOS, Windows, ZOS. There's the IBM ZOS. Where would ZOS be? There's a question for you. ZOS, which operating system is that? That is the IBM mainframe operating system. ZOS Wiki is the IBM mainframe IBM operating system. There you go. We also looked at statistics on operating systems and browsers and monitor sizes. We looked at the history between Microsoft and Apple and how Microsoft is founded on a lie. We saw that there's this great movie, which you are going to go watch. And we also learned about the kernel, which is kind of like, it's the central part of the operating system, which does all the main operating system functions. We learned about virtual memory, how when your real memory and memory, do you remember what memory is? Memory is RAM, random access memory. When your memory is full, the operating system will start using the hard drive and it'll pretend it's memory, but that slows the hell out of your system. So you want to make sure you have plenty of RAM. We also learned about buffering and spooling. So when you spool, it's the process of putting stuff into the buffer, and it's a way of the CPU processing all the data for a job for another piece of hardware all at once, and then putting all those zeros and ones into an area where that other piece of hardware can go and get them when it's ready for them. That's spooling and buffering. We learned about user interfaces, duh, and we also learned about virtualization, which is further utilizing your hardware to its fullest capacity and making sure that all your servers are being cranked up and maxed out, and that you're not, having a bunch of servers sitting there only running at 20 to 30% capacity. What you do is you get virtualization software like VMware, and you install that on your servers, and then on top of VMware, you could create virtual machines with virtual hardware environments with so it's like it's going to have this type of hardware specifications. And I imagine, I don't know much about virtualization, but I imagine that your virtualized environment would have the limitation of your actual physical environment. So if you're running this on a server with only 32 gigabytes of RAM, I doubt you could go into your virtual environment and say it has 32 terabytes of RAM. I don't think you could probably do that. But virtualization is creating virtual machines on one machine. And each virtual machine creates kind of like a sandbox where it could have its own hardware set up virtually, and it could have its own operating system, and it could run its own application software on top of that operating system. That is the virtual environment. An interesting statistic about that is 90 to 95% of servers only use 5 to 10% of their capacity, and that's from the VMware website. There's the hardware layer, there's the virtualization layer, and then each virtualized environment has an OS, and then apps run on top of that. And that allows for more centralization and thin clients, which is kind of interesting. There we go. That's what we learned so far about system software, in particular the operating system, because the operating system is a component of system software. And now we are heading into learning about utility programs, and we're going to learn about drivers, and we're going to learn some essential computer skills, all of these right here. And we're going to see how Linux is built, and we're going to learn a little bit more about Bill Gates. All right, this is your midway review, which I decided to do for this week because, I just felt like there's a lot of information. I just want to drive it home. And I made this as animated as I could because I wanted to make it interesting. And, I could have done it like this, but that might have been boring.